Okay, so we're just going to look at finding unknowns using real and imaginary parts. So I just want to explain first of all that if you have a complex number 2, is in the form of 2 plus 0i. And if you have a complex number, say 4i, that's the form of 0 plus 4i. So these consist of real and imaginary parts. Like 2 is a real part, 0 in that one is the real part. The imaginary part here is 0, and the imaginary part here is just the 4. So basically, if 2 plus 5i equals a plus bi or ib, the real parts will be equal. So the 2 will equal, I'll just do that in the same colour, just because it's nicer. The 2 will equal the a, and the 5 will equal the b. And that's called just equating real and imaginary parts. So a equals 2 and b equals 5. So what that allows you to now do, if you have an equation like this first one up here, 1 plus 2i, 1 minus 8i equals a plus ib, then basically if you can get this left-hand side here, so it is in the form of a plus ib, then you can equate real and imaginary parts. So you have to simplify it so you can put it in the form of the real part plus the imaginary part and then the I. Okay, so when you expand this, you get 1 minus 8i plus 2i minus 16i squared, because 2 8s are 16 and I times I is I squared. So it's 1 minus 6i minus 16. I squared's minus 1, so it's 1 minus 6i plus 16, which is 17 minus 6i. So if this is the same as a plus bi, then basically the real part will be equal, so a will be 17, and the imaginary part will be equal, so b will be minus 16. So a is minus 6, and b is minus 6. Okay, if we look at number 2, so number 2 basically is a over 1 plus 2i minus b over 4i equals 4. And we're trying to find a and b. So if you take this one here, 1 plus 2i first of all, and you realise it, or you multiply it by its complex conjugate, just to simplify it. Actually, you could probably do it, that's probably the easiest way. Just realise these. You could also multiply throughout by the common denominator. That would work as well. Might actually do it that way. So let's just get rid of the denominators. So you do it by 4i, 1 plus 2i, 4i, 1 plus 2i, and 4i, 1 plus 2i. You could have realised it and then multiplied throughout by the denominators as well. So the 1 plus 2i will cancel, the 4i will cancel, and then we have no denominators. Minus b times 1 plus 2i equals 16i, 1 plus 2i. Okay, so simplifying this and putting it into the form of the real part and the imaginary. Okay, so that's going to be 4ai minus b minus 2bi, because we just expanded, equals 16i plus 16 times 2i squared. So it's 4ai minus b minus 2bi equals 16i, and the I squared here will give you a minus 1, so that'll be minus 32. So we're nearly set up. We just got to put it in the form of real and imaginary parts. So the real part on this side here is the real part is the minus b, and the real part here is the minus 32. And then the imaginary part, we've got to put that together. That'll be the 4ai and the 2bi, and on this side is the 16. So I'm just going to factorise the I out of the 4a minus 2b. And on this side we have minus 32 plus 16i. So when we've done that then, you can see that the minus b will equal the minus 32. You're just equating the real parts. And the minus, make sure you collect that minus there. Just checking I've got the right signs there. Don't think I have, wait a minute. So I've got 4ai minus 2bi. That should be a plus because it's plus 4a. So the 4a minus 2b equals 16. So that means minus b is minus 32 and b is 32. And 4a minus 2b is 16. So we've got like two equations here. This one we already know what b is. So in place of the b, if we put 32, that will be 64 equals 16. That will mean if I add 64 to both sides, 4a would be 70, will be 80. Divide by 4, so a would be equal to 20. So it's just a matter with these of simplifying it and rearranging it. So first of all, you put it into the form, like you put both sides into the form of like a plus bi, and the other side into the form of a plus bi. And then you just equate the real and imaginary parts. And sometimes you'll form a simultaneous equation and you've just got to solve them for a and for b. So let's just look at this one as a third example. So I'm just going to get rid of the denominator straight out this time. So multiply everything by 2 minus I, 2 plus I, 2 minus I, 2 plus I, and 2 minus I, 2 plus I. So that means that that'll cancel. So you get 5a, 2 plus I, plus 2bi, 2 minus I, equals 4. Now let's expand this. That would be 4, and it's a difference of 2 squares minus I squared. So I'm going to take a shortcut because I know the two middles, minus 2i plus 2i, will cancel. So that's 10a plus 5ai, 4bi minus 2bi squared equals 4 minus 1 squared. So it's minus 1, so it'll be plus 1. So it'd be 10a plus 5ai plus 4bi plus 2b, because that I squared will give you minus 1, equals 4 times 5, which is 20. 10a plus 2b plus I, which is 5a plus 4b, which equals 20. Okay, so now all we've got to do is work out the real and imaginary parts. So what we need to realise, I've set it up on the left-hand side in the form of the real part and the imaginary part, but on the other side we have 20. So we go 20 plus 0i, because the imaginary part for 20 is 0. So now equating real and imaginary parts, the 10 plus 2b equals 20, and the 5a plus 4b equals 0. So that means that 10a plus 2b equals 20, and the 5a plus 4b equals 0. I'm going to divide everything by 2 here, because if I do that, it's just going to simplify it a bit more. So it's 5a plus b equals 10. And let's put this one under here, 5a plus 4b equals 0. So if I subtract these two, 5a minus 5a is 0, b minus 4b is minus 3b, and 10 minus 0 is 10. Divide by minus 3, so you get 10 on minus 3, and then you just need to sub 10 on minus 3, sub that into here, so get 5a plus 4 times 10 on minus 3 equals 0. So what have we got? 5a plus 40 with a minus on 3 equals 0. Bring that to the other side. So 5a is 40 on 3. And then we just need to divide by the 5. So if we divide by 5, it will be, we can put it in the calculator, but it's the same as multiplying by 1 on 5. 5 goes into 48, so you should end up with 8 on 3. And you could always check in your other one, in this one, just to check that it's true.